Good evening, everybody. Uh, Happy Friday. I'm having some funny hair days, so I'm sorry about that. Um, okay. Uh, yeah. Well, first of all, let me correct some error. You're right, Tom. Yeah, my math isn't that good, so I make a lot of errors. Yesterday we did this, okay, but actually this guy is alpha squared, okay. This is the first column, right? But just between 0 and 1. And so alpha squared and two times because including plus number, positive and then negative number. Okay, so 2 alpha squared larger than absolute value of q less than alpha cube, something like that. Okay, so and we realize this one has to do with the phi function, the Euler's torsion function. I'm sorry about my bad hair there. Okay, oh my goodness, that's so horrible. Yeah, so I did study some Euler torsion function in the YouTube and Wikipedia and stuff. So I share with you what I have learned from different lecturers in YouTube and different websites like Wikipedia, MathWorld, Wolfram. Okay, I share with you what I have learned about this Euler's torsion function phi. Okay, all right. We'll take 5 minutes break. Okay, all right. Yeah, we grab whiteboard and stuff. Yeah. All right. Ah. By the way, everybody welcome you. Even if we can disagree in ideological terms, but everybody's welcome here. Okay, I'm sorry I hurt to hurt your feelings a couple of days ago, but yeah, I am so sorry hurting your feelings. If I have, I apologize. Okay, all right. Let's find some whiteboard. Uh, we'll use this guy. All right, so I also apologize for bad hair day too. Okay. Uh, yeah, I can be somewhat mean sometimes. I am so sorry if I have hurt your feelings. Okay, I apologize. But let's move on, shall we? Yeah. Okay. Yeah, mathematics. Yeah. So okay. So after work, I watched some different YouTube instructors in mathematics. Um, so there's this formula. It's not closed form formula per se because nth prime number uh is unknown. That nth prime number closed form formula is unknown. Okay, so um yeah. So we are talking about phi, the Euler's torsion function, which is interesting name. It's not quotient, it's torsion. I have no idea what that means. Okay. Interesting pronunciation. So phi of n is equal to uh, n times pi uh, say pk belong to the prime factor of n, prime factor set. Okay, and then 1 minus 1 over pk. You multiply that and then multiply and then that's the uh, phi of n. Okay, and one way to prove it, this is very difficult to at least to me. They use like Chinese remainder theorem, which is also interesting name. Chinese remainder theorem, and then use some bijection concept, injection, surjection, bijection, this function concept. Okay, I did look at that proof, and also I did look at Chinese remember the theorem. It's too involved, and I didn't spend too much time trying to understand what they're doing. Okay, yeah, if I spend more time, yeah, I can understand that, but I didn't spend more time to understand it. Why? Because some other lecturer, he didn't quite prove this, but he hinted that it has to do with inclusion exclusion principle in set theory, and I think that would be a easier proof. But he didn't quite give the proof yet in that lecture. Okay, so we're gonna take a shot at that. Okay. So it's not my idea. I guess maybe somebody already proved using inclusion exclusion principle. They proved this formula already. Okay. It doesn't matter. Okay, we'll take a shot at it. So it's prime number set, okay, P, right? Yeah. P of n, prime number set of n, okay? prime factor set. Prime factor set. Okay, so yeah. Whew. And so it has to do with the like kind of the prime counting function pi of n, and we do know there's a prime number theorem. So we know asymptotic function of the pi of n, which is like prime number counting function, and using that, yeah, we can find out the cardinality of rational number q. Okay, so, which is really cool. Okay, so all right, so we're going somewhere, getting somewhere. Okay, so kinda, kinda. Okay, maybe this asymptotic function, big O notation of phi of n2. Yeah, we'll look at it. We'll look for it in the internet, cell phone. Yeah. Mm. Well, we need some room, so let's copy this over to the corner. Phi of n is equal to n times, oh, yeah, pi pk belonging to p of n 1 minus 1 over pk. Oh? Hey. Simplest example. Phi of 6. How many numbers out of 1 from 6, right? We are looking at uh, coprimes, right? Coprime of 6. So it's just 1? Okay. So we want to find coprimes, we want to get rid of all those things that well, 1, right? Yeah. And prime factorization, okay, so P of 6, 2 and 3, right? Yeah. So we're gonna subtract um multiples of 2. Huh? And also we're gonna subtract multiples of 6. I mean 3, multiple of 3. 2, 3, 4, 6. Huh? Yeah. Then the absolute value of this subset subtraction, okay? And this then is equal to 1, comma 6. which is 2. Okay? Yeah. Now, according to the formula, it goes like this, which is like what? 6 times 1 minus 1 over 2, 1 minus 1 over 3 is equal to? Yeah, 6 is 2 times 3, right? Send 2 here. And send 3 over there. 1 times 2, 2. Yeah, so this equation works, formula works, and we want to understand why. From, I am so sorry. There. Yeah, from set theoretical point of view, okay, so yeah, because some lecturer in the YouTube hinted at that, but he didn't quite prove that, but he hinted at that, and I agree. I think that's a lot easier proof, all right? Yeah, instead of using this Chinese remainder theorem, which is modulo arithmetic, the system of equation of in modulo equation, okay. Yeah, that's just too involved, okay, so it's cool proof, but we don't have time for that. All right, so we want to find the easiest way to prove this using set theory. All right. Okay. Wait a minute. I'm sorry. I made another mistake. Huh? I mean, even mathematics professors they make mistakes sometimes, and I'm not math professor. I'm just math amateur. Okay. How interesting. Okay. So if you recall, back in the days, we used to have this multiple set. All right. So multiple of 2. All right. Notation convention. Okay. 6m2 is all the multiples of 2, each of which is equal to or less than 6. Okay. So that's that. Okay. So here what we have is um um okay, multiple of 1, each of which is less than or equal to 1, I mean 6, right? And then you subtract 6m3, right? And then you what's left is let's say phi. Well, it's a set, so we gotta use the capital character, right? Phi of 6. Okay. Yeah. It's very obvious now, right? Yeah, very obvious. Okay, so because coprimes, okay, so number of coprimes under six. Yeah, yeah, yeah. So absolute value of five, six is lesser coprime set is equal to um, absolute value of 6m1 minus. I think. Mm-hmm. 6 minus 4, 2. Okay. Yeah, something like that. So, I mean, if we expand this guy, right? 6 times you have what? 1 minus 1 over 2 minus 1 over 3 plus 1 over 6. Expand that, then you come up with the same thing, right? 6 minus 3 minus 2 plus 1. Okay, so yeah, yeah. Okay, okay. It looks like that's the way to go. All right, so yeah, 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 yeah. All right, good, good. Yeah. We'll take 5 minutes break, okay? Right. Then I will bring this, turn this board so that you can see it. Right? So if you want to, okay? It's not that important. It's just something interesting. Right? Yeah. There we go. Ah, we shall take 5 minutes break. Okay. Oh boy. Yeah, I just made a quick lookup in the Google, and yes, it's already proven using inclusion exclusion principle, the phi function. Yeah, it's already out there, but we'll do so uh, as an exercise. Okay, so it's nothing new. It's already been done. Okay, so yeah, that's fine. But I'm kind of curious. Is there an asymptotic function for this phi function? Asymptotic. Yeah, some state exchange. Is it upper bound? Do they have upper bound? Oh, math overflow. Yeah. Not asymptomatic, no, asymptotic. Asymptotic. Yeah, there's some article in the archive. All right. Whatever. Hey. Yeah, I don't see any asymptotic behavior of this torsion function. So, um, okay. Well, mm, mm. It seems there's not enough study about this asymptotic behavior of this phi function. I guess there are some, but I tried to download it and it was taking forever. Okay, so uh, it was not a very big file. I don't know what's going on. So uh, we'll just do it. Okay, so it's shouldn't be that difficult. All right. Um, it's this. All right. This set. It's non-coprime set. All right. The number of non-coprime set. Yeah, we're gonna give it a name. We call it new, I guess, for n non-coprime set. All right. So your coprime set and non-coprime set. Okay. So okay. There's a partition of this set of natural numbers, lesser natural numbers. Okay. So okay. Yeah, we'll go ahead and do it. Okay, my cell phone is up. Let me give it one more try, okay, to download this thing. asymptotic growth of Euler phi function. This is phi n is about equal to n. All right. Okay. Okay. Well. I mean, if n is prime number, yeah, then that's true. But of course, n is upper bound. We know that. But as number gets bigger and bigger, prime number gets rarer and rarer, right? So upper bound is n. Okay. 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 Whew. Maybe we should just satisfy ourselves there. All right. Yeah. Maybe. Because this kind of inclusion exclusion principle, proving phi function out of that is already known. It's just they use just different notation convention, and yeah. So, but when it comes to this non-coprime function, non-coprime set, I think that may be worthwhile to look at. All right. So, okay. Mm-hmm. Yeah. Yeah, it gets way too technical. Okay, so oh boy, I'm not sure if it's worthwhile our time. All right, we are doing this for fun, right? Mathematics, and if we stop being fun, entertaining, then what's the point, right? There's no point continuing this if it's not fun anymore. So, all right, but I want to look at the paper that I tried to download. Download is not working. Hmm. Give me some time. What would be worthwhile activity, worthwhile at our time? Uh, I mean, so I looked up, and this kind of proof already exists. Just they use different symbols. Then I don't quite feel like doing this using our symbols because I don't see much point of replicating other people's effort because it's already done. It kind of sucks the fun out of it, right? If it's something very forced in time, then yeah. But if not, well, mm, mm, well, at least we can make some pedagogical improvement, all right, to the understanding of this torsion function. Okay, so we'll just do one more, all right? Then we move on. Okay, potentially. We'll do 2 times 3 times 5, which is like 30. Right? So, yeah. Let's grab a new whiteboard and just see what it looks like. Okay. Yeah. Because from the lectures in YouTube about this Euler's torsion function, yeah, it was not very easily understandable. All right. So, at least for pedagogical, instructional improvement, I think that's was what our time. Okay. Yeah. Mathematics education. Okay. Okay. Yeah. Let's do that. Yeah. We'll take 5 minutes. Okay. So. Okay. Yeah. Hmm. So, by the way, happy Friday. Happy Friday. Yeah. Yeah, let's continue with this stuff. I'm sorry if I'm boring. Ah, okay, we put it right here. Uh, Okay. Ow. All right. How about this guy? Yeah, I'm sorry. It's kind of dry. We're dealing with mathematics. Yeah, quite a dry subject. It's like dry desert landscape. But there's some beauty in the. Have you been to desert? Isn't it beautiful? There's some beauty in this dry desert mathematical landscape here. Uh, okay, so 2 times 3 times 5, 30. Number 30. Okay, uh, so we're talking about co-prime set phi of 30 is equal to 30, and is the natural number less than or equal to 30, starting from 1. Okay, so minus um, set of multiples under 30 union set of multiples of 3 union set of multiples of 5, because that's the prime factorization of 30, 2, 3, and 5, right? We're gonna have to give this guy a name. Okay, so non-coprime. Okay, non-coprime set. Um, will because um, okay, so we just call it because that's what it is. All right, complement. Okay, so yeah, coprime set, non-coprime set. Okay, that makes sense. Oh, it's chilly. Ooh. Okay, I just keep lingering in my mind. I'm sorry about being mean sometimes. Like I talk about these ideologies, but I don't mean to exclude anybody. Okay, it's just that sometimes I feel strongly about those ideologies that I do not subscribe to. Okay, so but everybody's welcome here, and I love you no matter what your ideological subscription is. Okay, so but every now and then, yeah, I talk about those things like my opposition about certain ideologies. Okay, but I don't have anything against people. Okay, just I have things against ideologies that I disagree with. Okay, that's all. Okay, but sometimes, yeah, I kind of say mean things in social media. I shouldn't have. Okay, I should stop doing that because I might get sued. Intentional infliction of emotional distress, IIED. Okay, I don't want to get sued. I don't want to lose my savings, or I may get even charged like harassment or stalking, or if not federal hate crime. Well, they're too far fetched, but yeah, I should stop hurting people's feelings. I guess. Yeah, yeah. I repent. God, please forgive me. People, please forgive me. I stopped being rude. In Jesus, Amen. Okay. Oh, I repented. Okay, so all right. non-coprime set, right? So now, if we put absolute value, that's cardinality. Okay, so yeah, it's just ex- inclusion exclusion principle, right? Yeah, because I think by offending people, by criticizing their the ideology they subscribe to that I don't like. Punishment time, okay, yeah, like I'm sorry, like 100 times, blackboard back in school days, kind of thing. Okay, so yeah. Oh, huh. Hey. So here 30m2 is just the number of absolute value thereof. It's the number of elements, number of numbers under 30 or 30. There are multiples of 2. So how many of them are there? 15. So we just 30 divided by 2. Okay. Hmm. Minus. Okay. Multiples of 2 and multiples of 3. Intersection. That's multiples of 6, right? So how many multiples of 6 are there on the 3? On the 30? Yeah. Oh, plus 30 divided by. Okay. All right. Yeah. So it's we need to factor this out somehow, right? We need to factor this. Basically, we are trying to prove Euler's torsion function in terms of set theory, which has already been done by some other people. Okay, but the way they did it is not very easily understandable, right? So that's why we are redoing it. Some enhanced pedagogical method so that more people can understand torsion function more easily. Okay, that's what we are doing. Okay, is it worthwhile our time? Yes. Why? Because we are improving education, mathematics education. Okay, I think it's worthwhile. Right. So yeah. Somehow we need to factor this. Okay, so we're gonna need another whiteboard. Okay, so bottom line is okay. Bottom line is this. All right. So uh 30 minus all this. Okay, 30 minus let me write it again. Okay. And this is 5 of 30. Okay. So torsion function. So we need to factor this out somehow. Okay. Yeah. We'll take 5 minutes break, okay? And then we'll substitute 1 over half. We'll call it A, B, and C. Okay. To make it easier. Alright? Yeah. And we factor it. Okay. Okay, we'll take 5 minutes. Okay. Okay. Yeah, we're gonna have to find another whiteboard, huh? Okay. Uh, uh sure. We'll use this guy. Yeah, I took a picture of this. It's tape recorded, so yeah, no problem. Erasing it. So saved somewhere. So, uh, I gotta vacuum my floor tomorrow, Saturday. Okay. So, yeah, I kind of want to keep doing this because it's not polynomial, but multiplication of the terms, right? I guess we can come up with a nice way to express this inclusion exclusion principle in a more understandable way. I just looked it up in the Wikipedia when I was taking cigarette break, and it's not very on good form the way they express the inclusion exclusion principle. Okay, so we come up with a better way to express it. Okay, yeah. So, more understandable way. Okay. Right. Let's get to the basics. Okay. Before we factor it, let's just distribute it. All right. So 1 minus a, 1 minus b, 1 minus a plus b plus ab. Right? Yeah. No. 1 minus a, 1 minus b, 1 minus c, 1 minus a plus b plus c, plus ab, ac, bc, minus abc. Right? Okay. And so on. Okay? In set theory. Okay? Absolute value of A union B is equal to A plus B. Well, some notation convention here. Okay, so okay, A notation convention. Okay, where absolute value of A is just A. Defined as AB. Okay. Okay. If we adopt that notational convention, then This is equal to 1 minus 1 minus A, 1 minus B. Okay, so, and what is 1 in set theory? We have to translate that. Okay, what is 1? Interesting, huh? Okay. Good question. We are trying to connect algebra and set theory. This can be something brand new, okay? So, yeah. We're trying to connect algebra and set theory, okay? So, it could be something brand new, okay? So, all right. Yeah. I'm looking at the whiteboard over there, okay? So, okay. Where's another whiteboard? Ah, boy. Right here. Okay. Ah. So you have 5 of 6 is equal to 6 minus 2, 3 plus 2 plus 1, which is 6m1 minus 6m2 plus 6m3 plus 6m6. Okay? Alright. Well, 6m2 intersection, I mean, 6m3 absolute value. Okay, so absolute value. Yeah. I think what we are doing here have some good value. Okay. Boy. Let me bring it closer so you can see more easily. It's too close. Oh, don't fall on me. That was close. Ah, boy. With this algebraic structure, multiplication of those terms, we expand that. Yeah, it has to do with this inclusion exclusion principle in set theory. Okay, there's some similarity between those two things, and we kind of know why, but we want to understand. We want to get to the bottom of it. All right. Hmm. I want to know the meaning of one here. All right. In set theoretical language, in the language of set theory, what is this one? One is in algebra here. Okay, so trying to understand. Hmm. In set theory, what would this one look like? So in set theory, let's write it out. 6m2, that's all the multiples of 2, less or equal to 6. So, okay. 6m3, all the multiples of 3, each of which is less than or equal to 6. Alright. And 6m2 complement is all the numbers excluding this guy. 1, 3, 5. And 6m3 complement is equal to all the elements excluding this guy. So 1, 2, 4, 5. Okay. So 1 here, well, here is 6. Some superset, bigger set, that's what 1 stands for. In this example is 6. All the natural numbers from 1 to 6. Okay, so we're kind of constructing that, huh? Okay, okay. A and B. We're constructing some kind of superset here, all right? Yeah. I mean, by default, trivially, we can set one as the because one and one it cancels out anyway. We can see that as just A union B absolute value. Okay, yeah, we can do that, or maybe something else. All right. But in this example, okay, it's just multiplication of two and three, six. Okay, okay, yeah, one. Yeah, I guess it stands for union, right? Yeah. Okay, okay, that's fine. Okay. Ah, boy. I'm not good at mathematics. I'm fumbling. All right. So yeah. Oh well. Hmm. Let's just for fun. Let's do factorization. Okay. So it's been a long time. Let's do some factorization. Right. So this guy. Okay. You one minus a plus B plus C. And you get BC and 1 minus ABC. Okay, so BC 1 minus A. Okay, yeah. Then you have minus B plus AB. Okay. Minus C and you have AC. Minus C plus AC. Okay, so no, sorry. Minus C plus AC. A minus 1. Okay, so minus B plus AB. Okay. Factory roll out. You have 1 minus A. Uh, what did I miss? 1 minus A. Okay. Okay. B, this is like minus B times 1 minus C minus C minus 1. So, uh, I mean, plus 1 minus C. So you have 1 minus B, 1 minus C. Okay. Oy. Mathematics. Such a mess. Oh. L is in my head because I'm not that good at it. Okay. I mean, set theory was developed way after, like, about 200 years after Euler's time. Okay. So Mr. Euler, he was just doing algebra, right? Yeah. So set theory is later development. And we found some interesting similarity between algebra, Euler's algebra, and set theory here. Okay, so yeah, we want to further investigate that, and I'm not very doing a good job here. Okay, so we'll just take time. Okay, so yeah, I'm fumbling, because I'm not good at mathematics. Okay, but okay. In this red cup, there's just water. Okay, yeah, just water. Yeah, because what I want to express is you have this formula for inclusion exclusion principle, right? Yeah, I mean, some sigma, yeah, we get it, but we want to express in terms of this multiplication of terms like that, because they'll be a lot simpler, right? Instead of sigma, we want to express inclusion exclusion principle in terms of pi multiplication, okay? So that's what I'm struggling to find out here. If you go to Wikipedia, yeah, inclusion exclusion principle, okay, like you have what, k from 1 to n, a k, union, that's equal to, like, you have sigma. I don't even know. Yeah, we take time, okay, so yeah. I mean, Wikipedia, they don't quite do that, but the way we used to do it before here, um well, we express that, okay, but Wikipedia, it didn't really help very much, okay, so their notation convention, yeah, it's good, but I want to find a better way to express it. Okay, so we'll take time. Okay, this is gonna take a while, right? We'll take 5 minutes break. Okay, so yeah. Oh yeah, we'll take a break. Ooh, this is hardcore. Ooh, very refreshing. Let's take a break from all this, okay? So, yeah, let's take a break from all this. We need some break. So, yeah, in the social media, I wasn't like a troll. I was more like a ministry, like a missionary, okay? When I saw this in the social media, some LGBT community members, I said something like, yeah, I think you need to repent. Such a mean thing to say, right? Yeah. You are influenced by this LGBT ideology, so I hope you repent. I pray for you. I said something like that, okay? So I didn't call any names, vulgarity, no. Yeah, but still, I think it can be very offensive, so I stopped doing that, okay? That was a break. We are busy, okay? So let's continue, okay? So we have to do this. We have to do this. Why? There's nobody else. We are the only one who can do this, okay? So algebraic set theory. Okay, so some brand new mathematics. Okay, so we are connecting algebra and set theory, all right? Because we observed something, some similarity between algebra and set theory. Okay, and we don't want to miss it. Yeah, this opportunity. Yeah, yeah. Okay. I mean, you don't have to do this. Okay, I have to. It's my mission. Okay, so mathematical missionary. Okay, so all right. So traditionally, right? Yeah, traditionally inclusion exclusion principle. Okay, so you have absolute value of A1 union A2. We just call it A1. Okay, A1 by definition is absolute value of A1. Okay, so and then A1 A2 by definition is like okay. We just spat it out because I have sinned. Okay, sure. As a punishment, very inefficient way of expressing the idea. So we want to find a list of better notational convention, okay? Yeah. So how do you express that in terms of sigma and whatever? Okay, so uh, here you have intersection k from 1 to 3, ak, right? Here you have sigma, right? Some kind of sigma. Ay. One, two, one, three, two, three. Okay. Ah, we did this long time ago, right? Yeah. Yeah, it's like, eh. Yeah, it's not easy to define this. Oh boy. Ah. So yeah, combinatorics, right? 3C1 is like 1, 2, 3. 3C2 is like 1, 2, 1, 3, 2, 3, right? Three C three is like 1, 2, 3. Okay, so all right. Combinatorial set. It gets very icky. Ah. Yeah, we're gonna have to define some functions, right? So within the parentheses, we do intersection, right? Outside of parentheses, we just sum them up. Okay. And we apply this indices to A. It's some kind of transformation function, all right? Yeah, A1, A2, A3, and we transform these commas into plus. Okay? Some strange transformation function it will be. Okay, so it's like computer programming, right? Yeah. Within the parenthesis, yeah, comma becomes intersection, right? A1, A2, A3 intersections, okay. But outside of parenthesis, these commas within this curly bracket, it becomes plus. Okay, some transformation function. Okay. Okay. You know, continue on this tomorrow. All right. This is like gigantic task, right? And we'll continue tomorrow, right? It's Friday evening, and then I'm kind of drunk, and I have some other things to talk about. Okay, here, all right. We'll take 5 minutes break, and we'll continue mathematics tomorrow. Okay, yeah, algebraic set theory. Okay, something brand new. Okay, so we'll continue on this tomorrow. Okay, and we'll take 5 minutes break. We'll talk about something else, and then we'll wrap it up for tonight. Okay. So I had a pretty long day at work. Okay, I stayed at work until like 7. Okay, so okay, all right, we'll take 5 minutes. All right, we'll talk about something else. Okay, so for the rest of the tonight. Yeah. Okay, ladies and gentlemen, we did enough mathematics for today. Okay, so let's stop. It's just too much, right? Yeah, we'll get to the bottom of this brand new mathematics, algebraic set theory tomorrow. Okay, so uh, I'm gonna tell you about dream I had a couple of nights ago. It was a very interesting dream. It was like, can you take a guess? I give you a minute. Okay, so it was interesting dream. It was like spectacular. I give you a minute. It was about. It's not a minute yet. Okay, so yeah, it was spectacular. Okay, and it was scary too. What was that dream about? Flood, like Noah's flood, great flood. Okay, this tsunami, this big wave of water. Right? Yeah. I was in a building. Right? It was some school building. I don't know what building it was, and we saw this big wave of water, blue, ocean blue water, as tall as a building, okay, coming at us toward our building. It was a big building, like 5-story building, okay, old school brick building, kind of light brown, okay. There were a bunch of us, maybe a dozen, 2 dozens, okay. What were we doing there? I don't know, maybe some school cafeteria. I don't know. 5-story, maybe 10-story building, okay. So about 2 dozen of us in the building. Okay, we saw over the window, yeah, this big wave of water, like tsunami, coming toward our building. Right. So what do we do? There was me and another guy going up the stairs. The rest of them they didn't go up the stairs, okay? But me and another guy, we start climbing up the stairs to get on top of the building so that we don't get drowned, right? So yeah, he went his way, I went my way, okay? Both of us, we tried to get on top of the building. Other people didn't. Okay. Why? I don't know why. So I was just like going up the stairs to get on top of the building so that I don't get drowned in this water tsunami, big wave, and then I went somewhere. It was big empty space in the middle of building. Okay, there's no more stairs, so I start climbing up the ladder, right? And then this cord, like electric cord or whatever, beat with my belt, like whee, like movie. Okay, and then I went to a hole. It was a slide. Oops, I'm going down. Oh, what a mistake, right? So I got inside of the water. Okay, after this wave hit this building. And I looked up and there's some water on top above with some flame, some fire. It makes no sense. It's a dream. Okay. So, but there's some fire. Okay. But I was under that fire on top of this wave. Okay. Whatever. And it's a dream. Okay. I'm just describing the dream I had a couple of nights ago. Okay. And then through the ocean wave it threw me to Oregon, some forest in Oregon. Okay. Okay, so I landed with somehow I had blanket using as a parachute, something like that. Okay, so yeah, I landed in a forest. It was at night, somewhere in Oregon. Okay, okay, so I was walking around, yeah, with my blanket like a homeless person. Okay, somehow I landed in this Oregon forest with trees and woods and yeah, I was just walking around. Right, it was dry land. Somehow I landed dry. Right, it's a dream. Okay, it makes no sense. Okay, so yeah, I was walking around, looking for some establishments, buildings, whatever, and then I saw this one building, dry, no water. Okay, and I went there. It's an empty building. By then, it was like morning in the morning or afternoon. Okay, so I looked. It was very old and abandoned, dilapidated building. I think it was like school building. Okay, very dirty, abandoned, dilapidated, blighted school building. Okay, just one stair, no second stairs. Okay, so yeah, I looked around, got inside the building, and then there was some dirty, old, dilapidated, abandoned refrigerator. I opened it because I wanted some food. Okay, and there's some rotten food in there, so I closed the refrigerator, although I didn't have to. And I started walking, okay, and I saw another guy, some Caucasian gentleman in his 50s, I guess, some white mustache. Not too old, 40s, 50s, older than me though. Okay, so I was like, "Hey, Mister, yeah, ah, I wanna go to Portland, Oregon. Okay, so is it that way or that way? Should I take a bus? Because I wanna get back to Alaska." And the gentleman said, "Okay, well, hey man, nothing is free. Young man, nothing is free." Okay, he was older than me. Okay, maybe in his 50s. Okay, so Caucasian gentleman. Yeah, nothing is free. Okay, I can give you direction. Okay, so but I have cigarettes. I want to smoke cigarettes, but I don't have a lighter. Do you have a lighter? Oh yes, Mister. So yeah, I lighted his cigarette and okay, yeah, you go that way. Okay, you take the bus and go that way. Hey, Mister, do you have some money token for bus fare, bus fee, bus ride? Oh, I'm sorry, I don't have that. And then there's some Asian American guy walking by, okay, By then, we were on the street with some cars going. And this Asian American guy, he was younger than me, like late 30s, early 30s or late 20s, kind of mid 30s, Asian American. He said, "Oh no, no, this guy, this Caucasian gentleman, he's just kidding. Okay, it's not that way. It's the other way. Okay. Oh, okay, Mr. Asian American gentleman, younger than me. You are in your early 30s. I'm my early 40s. Okay. Yeah, thank you. But I don't have any money with me. Can I borrow some money? Borrow from you some money? Or do you have some bus token, some coins?" And he said, "Oh yeah, here's token. Okay, yeah, there's the bus. Okay, just take the bus. Here's the bus token. Okay. Oh, thank you, Mister." And then I took the bus and dropped the token, bus coin token. Okay, and got in. And then this tsunami came to us again. Okay, big wave. But bus driver, he was African American gentleman. Okay, he was still able to drive in the water, great flood. Okay, and then the bus, more water came to us, and then the bus started to float in the water, and it started to sink. Okay, there are dozens of us in the bus, but so I climbed out of this bus window to get on top of the bus because it was sinking. Okay, other people they didn't try to get on top of the bus. I guess I don't know. So I got on top of the bus. It was sinking, and it was great flood, this big blue ocean wave, and the bus was sinking. So I jumped from this bus on top of the bus to another floating vehicle. It was a truck, cabin of the truck. Okay. Somehow it didn't sink. It was floating. Okay. And then I woke up. Okay. Later on, maybe 1 or 2 days ago, 2 nights ago, I had another dream. And that dream was interesting. And it was, I'll tell you, okay. I was in a building, like as usual. And then in this building, it was some kind of dirty bathroom. I was looking for water, some fountain, so that I can drink some water. Okay. Yeah, it was very dirty bathroom, and other people there, they were like doing some strange things, like yeah, something very unethical things in some bathrooms. There were like 2 dozens of them. Okay, doing some dirty things in the bathroom. All right, I'm not able to tell you what they were doing in my dream. Okay, but I didn't want to take part of that things that they were doing there. Okay, unhealthy things. So I wanted to get out of there. Okay, and somebody grabbed me, my arm. Okay, then I shook it off to get out of that dirty bathroom because I did not want to participate in that activities that they were doing in this dirty bathroom. Right? So I tried to get out of this dirty bathroom. I tried to find water. Water faucet was not running, so I tried to get out of there. And somebody said, "Hey, stop! Don't leave! Don't go! Join us!" I was like, "Oh well, thank you, no, thank you. Okay, I just want some water to drink. This dirty bathroom has no running water, so I'll leave. Okay, bye." And somebody grabbed me on my arm, right up. I shook it off like this, and then I woke up. As I was waking up from this nightmare, yeah, I remember I did physically jerking motion, shaking off this somebody else grabbing my right arm. Okay. Then I woke up. Okay. Interesting dream. So then I was thinking, okay, this ideological tsunami, you have LGBT, you have tattoo piercing, or all this unclean spirit as opposed to Holy Spirit, okay. Yeah, many people, most people, they just go along with it. When the tsunami, big wave come, they don't try to escape it. I did. Some other people did in my dream, okay. They go along with it, okay, and they die, they drown, and they become part of this wave, tsunami wave of these unclean ideologies, tattoos, piercings, LGBT, marijuana. Oh, there you go again. There we go again. I'm sorry, okay. All this BLM, this hyper pro feminism, hyper pro Semitism, whatever, okay. Einsteinian relativism, yeah, they just drown in that big ideology and they die, they become zombies. And dead fish in the ocean, dead fish in the sea. They become part of this wave, ideological wave. But me and some other people, we resist those ideological trend. We want to get on top of that ideological wave, tsunami, right? Because we want to resist and we want to survive. Ideologically speaking, we do not want to drown and die, become some dead fish, dead zombies, and become part of this wave, ideological tsunami, right? But that's how I interpreted this dreams. Yeah, President-elect Biden, okay, pro LGBT, like pro BLM, pro hyper, pro feminism, pro whatever. Okay, so but at least he does diet and exercise. He's fit. Dr. Fauci, I'm very surprised to find that recently. He's 80 years old. Very fit, healthy individual, Dr. Fauci, okay, very President-elect Joe Biden, fit individual, diet, exercise, okay. Unlike President Trump, okay, but yeah, nobody's perfect, goods and bads, right? We all agree, disagree on different perspectives, different issues, okay? Yeah, but I don't know, like President Trump, President-elect Joe Biden, they have goods and bads. Okay, so President Trump, he could not fire Dr. Fauci. Why? He's not hardcore. He's too afraid. But Dr. Fauci is very popular. Okay, he don't have guts to go against Dr. Fauci. Okay, so, but I'm impressed that Dr. Fauci, in his age, 80 years old, very fit, diet exercise. Okay, that's good. I can appreciate that. President-elect Joe Biden, yeah, in his late 70s, very fit. He could still run. I saw him running. Mask on. Not smart, okay. But, yeah, he's very fit, okay. So President-elect Joe Biden, he said, Dr. Fauci, he will keep him on. Yeah, whatever, okay. But, yeah, they're impressive Caucasian males. Very fit individuals. No obesity. They do diet and exercise, I guess. But President-elect Biden, yeah, he's hiring a lot of females and ethnics. It's not too bad, okay, but when he hired these LGBT people, yeah, I'm like, there he goes again. Democratic Party, liberalists, okay. I mean, I'm not against people. I'm against LGBT ideologies, right? So that's my concern. And yeah, when he hired these LGBT people, like former mayor Buttigieg, whatever. Okay, he's approving LGBT ideology, and that's a big mistake, in my opinion. Okay, but that's just me and some others. Okay, so I'm not too worried, but it's a little bit concerning, right? I mean, southern border wall is a good concept by President Trump. Okay, you have house, apartment, your home, you have walls. Okay, because you don't want to house all the homeless people, jobless people in your home because you don't have that kind of money. Southern border wall, yeah, same concept. Okay, you cannot just let them in. Okay, you don't have that kind of money, right? So it makes absolutely no sense that we don't have any border wall. How about between Canada and America? Well, Canada and America, Canada people, yeah, they make enough money. They're not gonna come to America, right? Crossing the border. But when it comes to Mexico and America, there's an economic gap, right? Mexico, I've been to Mexico. It's a beautiful country, wonderful people, fantastic culture. Okay, but when it comes to money, yeah, Mexico have a lot of problem with drugs, gangs, right? So yeah, we cannot just let them in, right? Yeah, whatever. Okay, so there's some concerns about VP Biden, but we have God if you're religious, right? I'm religious. There's still many good Americans. I've seen many good Americans. Sodom and Gomorrah, yeah, homosexuality, all that stuff, okay. Or Pompeii in Roman Empire, okay. But when it comes to Sodom and Gomorrah, Abraham asked God, "Hey, would you destroy this Sodom and Gomorrah, my hometown, if I can find 10 good people in Sodom and Gomorrah?" God said yes. When it comes to America, are there more than 10 people, 10 good people in America? If you ask me, yes. Okay. Hopefully God does not destroy America. Okay. Look, 110 people voted for me in this town, okay, in the valley, right? So there are more than 10 people outside of Alaska, outside of the valley. I have more friends who would have voted for me. Okay, so I'm not too worried. Okay, so I think God, I hope God spare America and doesn't. Hopefully, America does not become like Pompeii, Roman Empire, or Sodom and Gomorrah, or Noah's grass flood. Hopefully, it doesn't happen in America. Okay, so because there are more than 10 good people in America. In Alaska alone, I know there are more than 10 good people in Alaska. Okay, so even people who are tattooed and pierced or LGBT community members, I know some good people in those communities. Okay, so they're not all that bad. Even in marijuana community too. Okay, yeah. Many of them my friends. Okay, they're not all that bad. And look at me, I'm not all that good. I smoke cigarettes, drink alcohol. Okay, so nobody's perfect. All right, so we are all vices. We are all sinners. Right? We are all dumb. So let's just forgive and forget. Right? Try to tolerate each other. Okay. Yeah, so tomorrow we continue this mathematics, okay? We try to express that inclusion exclusion principle. Yeah, it's quite involved. All right, so we are trying to find the right language for it. All right, so okay. All right, thank you. Happy Friday. Happy holidays. Bye.